All right, so if you've made it this far, you're probably looking at this and going, oh my God, this is stoichiometry. It has nothing to do with gas stoichiometry, and you would be correct. So, those of you who have watched this video up till this point, or these videos up till this point, I'm letting you off the hook. You do not have to do, let's see, this one has nothing to do with volumes. This has nothing to do with volumes. What volume of hydrogen gas in liters is formed in an STP? Now, I like this one, but I only like part of it. So I'm going to do part of this. I'm going to do what volume of hydrogen gas in liters? STP. Okay, so I have 156 grams of potassium metal. That's this. All right, let's do some stoichiometry here. We have, this is going to be grams to moles. So I'm going to do a 2-box, and I'm going to do moles of hydrogen gas. H2, that's this. So this is mole H2. And that's as far as I can go do in that direction. So let's start this direction, 156.0 grams of potassium metal. Oh man, now I need a wait a minute. Don't we have a periodic table? We do. Hang on. Where is it? Grams, so it is grams potassium, and that is 39 grams per 1 mole potassium. This is mole of potassium. This looks like the heart of the problem. 2 moles over 1 mole equals. Okay, so the first part of the problem is 156 divided by 39 divided by 2 equals 2 moles of H2. And then 2 moles of H2 times 22.4 liters per mole equals 44.8. I can do that math in my head. 44.8 liters of H2. There we go. So that's something realistic. Now, let's see what else we can find in here that might be worth our while. Grams, moles of carbon dioxide. Again, they're not asking us for any volumes. Has nothing to do with the test. You know, I really should look over what these people give me to give you day in and day out more often. Let's see. Volumes of 2 gaseous products. I see one that looks worthy of being done. Okay, what is the volume of these 2 gaseous products? So, how many grams of carbon dioxide gas and water vapor? Is this balanced even? Oh, no, it's not even balanced yet. Awesome. Awesome. Yeah. That's 5. That gives me my 10 hydrogens. And that gives me 10, 12 oxygens. Okay, so, and then we're going to do 4 of these, which is going to give me another 8 oxygens, so 8 and 5, 5. Oh, that's a problem. That gives me my 10 hydrogens. That gives me 5. That's 13 oxygens. We can't do that. So what happens if we do 6 here? No, can't do that. I didn't want to balance things today. 2, that's 8, and that's 20. Okay, so 8 and 20. 8 and 20 hydrogens, so this is 10, so it's 10 oxygens. And 8 oxygen is 16, so that's 26. 26 oxygens. So out here I need a 13. Does that round nicely into shape? 8 carbons, 8 carbons. 20 hydrogens, 20 hydrogens. 26 oxygens. 16 plus 10 is 26. Okay, now that we've balanced it, let's see what we can do with it. All right. Now, how many grams of carbon dioxide and water vapor? I'm going to figure out how many moles of each. I'm going to say I start out with 11.6 grams of butane, and this looks like it's going to be 2 more 2 boxers. 11.6 grams of butane. Butane, C4H10. C4H10. So this is grams of C4H10. Grams of C4H10. 1 mole C4H10. 1 mole C4H10. This is going to be moles of H2O. Moles H2O. Moles C4H10. This is 10 moles of H2O. 2 moles of that, and this is going to be equal to moles of carbon dioxide. So moles CO2, moles C4H10. I know I'm being extremely messy, but I'm kind of ticked off about this anyway. So 8 and moles of C4, let's see, 2. All right, so now we got some calculations to do. 11.6. Oh, wait, we got a 12 times 4 equals plus 10 equals 56.48. How's that possible? 12 times 4 equals plus 10 equals, yeah. 50, no, it's 58. Donkeys. 58 grams per mole, 58 grams per mole. Okay, now we can do some math. 11.6 times 8, enter, divided by 58, enter, divided by 2, enter. I have 0.8 moles of CO2. 11.6 times 10, enter, divided by 58, enter, by 2, enter, equals 1 mole of H2O. So 1 mole, I know what this gaseous volume is. It's 22.4 liters of water vapor in gaseous form. if it truly is. And this is times 22.4 equals liters per mole, 0.8 times 22.4 equals 0.8 times 22.4 equals 17.92 liters of CO2 in gaseous form, and together plus 22.4, the total is 40.32 liters of gas in this equation. All right, what else can we look at? Molecules with volume of sulfur dioxide produced. 3 moles. How many moles and molecules of sulfur? Okay, so that's nothing. And volume of sulfur dioxide. So if we start out with 3 moles, okay, so it's a 1-to-1 mole ratio here. So calculate the volume of sulfur dioxide in liters. Not a problem. If I have 3 moles of sulfur, then I have 3 moles of sulfur dioxide. If I have 3 moles of sulfur dioxide times 22.4 liters per mole equals 3 times 22.4 equals 67.2 liters. Liters of sulfur dioxide. There. Calculate the volume. Yeah, I did that. I'm not going to calculate moles and molecules. We did that enough when we did stoichiometry. Okay, ooh, there's a word you're going to see maybe one day. The Haber reaction. 170 amine, how many grams, how many molecules of each reactant? Nope, don't care. Oh, what we got here? Number 8. If 44.8 liters of hydrogen gas are formed at STP, then how many grams of sodium and water are needed? Oh, should I do that to you? Should I make you convert from liters to moles and then do moles to grams of sodium and water? Do you know how many? Oh, no. No, I refuse. I refuse on general principle. The face of it is wrong. Okay, let's see if we can find something else that's worth doing here. How many moles of hydrogen gas and oxygen gas are needed to produce 11.2 liters of water vapor at STP? How many molecules of each reactant? Okay, well, I don't like that. And really, we haven't done enough. 11.2 liters of water vapor. So I have 11.2 liters, so it'll basically be a mole to mole. And that would be pretty easy, wouldn't it? Yeah, all right, let's do it. So we have 11.2 liters of water vapor, H2O in gaseous form. And if I divide that by 22.4 liters per mole, that cancels that out, and that equals moles of water vapor, H2O in gaseous form. Let's see. 11.2 divided by 22.4 equals, I have half a mole. All right, and then they want how many moles of hydrogen gas and oxygen gas. So we have to do 2 separate mole to moles. So we have 0.5 moles H2O, and we're going to do a 1 boxer with moles of hydrogen gas first, H2. All right, moles H2, moles H2O. Okay, moles H2, moles H2O. Rules still apply. Units have to cancel. These units are the units of our answer. Moles of H2O. Well, that looks like 1 mole. Moles of H2. Well, no, I wrote it up here. It's still 1 mole. 1 mole. Oh, it's not balanced. Dang it. We have to balance it. Sorry. 2 moles of H2. And 2 moles of H2O. Not that it's going to change the answer much. 0.5. So it's a 1-to-1 mole ratio, 2-to-2 mole ratio. It doesn't matter. It's the same thing. And we've got one more to do, 0.5 moles of H2O. Oh, see, I'm getting lazy. Moles of H2O. And we want our answer in moles of what else? Oxygen gas. O2, moles of O2. That's 1 mole of O2. Moles of H2O. That's 2.5 times 1 is 0.5 divided by 2 is 0.025 moles. Okay, what else do we have? Molecules, grams liquid. Oh, here we go. Number 12. We might want to do number 12. Actually, this video is 15.5. No, 16 minutes long. How many grams of hydrogen chlorine gas? 46. What volumes of gaseous? No, we're just going to stop here. If you did that much, then that's enough. And I hope everybody aces this test tomorrow.